Welcome to Ceres Reimagine 2023, our clean energy competition. I'm Caroline Hargrove, Chief Technology Officer for Ceres, and I'm thrilled to once again be a part of this excellent competition. As CTO for Ceres, I'm used to pushing innovation and overcoming challenges. As a judge for last year's Reimagine, I was very impressed at the level of creativity and ingenuity students just like you showed in their entries to the competition. I know I'm going to be wowed once again as you share your original and creative ideas to tackle the mission for net zero. Ideas submitted as a video everyone can understand. We'll be looking for creative skills, depth of research, and how far your ideas can have an impact on climate change. Are you ready for the challenge? Go to ceres.tech/reimagine right now and start to work on your clean energy ideas. I look forward to seeing what you come up with.
Imagine a world with zero greenhouse gases. Imagine a world that simple. Blue lakes, green trees and carefree animals roaming the earth.
Now, imagine the same world but with factories and dead and dying animals and fading plants. The earth filled to the brim with landfills and toxic gases. Earth just wouldn't be the same, would it?
We now know about our endings, but what about what led us here? This is where net zero comes into play. So, jury, did you have any questions for our defendants?
What is net zero?
Net zero is the action of taking away the amount of greenhouse gases produced by humans every day by reducing emissions and using methods of taking in carbon dioxide from the atmosphere.
When will net zero start taking effect?
Good question. Net zero will be possible by 2050.
Is net zero enough?
Fortunately, net zero itself was not enough to save our planet, which is why we need to come up with more solutions in the future to help.
What are some positives about net zero?
Greenhouse gas emissions will be as close to zero as possible. Remaining emissions will be reabsorbed from the atmosphere.
How does CO2 get into the atmosphere?
Human activities that lead to CO2 emissions come primarily from energy production, including burning coal, oil, or using natural gas, which are non-renewable energy sources.
A negative is that it may not be enough, and it could be hard for everyone to get involved.
What are some examples of non-renewable energy?
Petroleum, hydrocarbon gas liquids, natural gas, coal, and nuclear energy.
What are some examples of renewable energy?
Some examples of renewable energy are solar, wind, hydro, tidal, geothermal, biomass, etc.
What can we do to reach this?
There are a lot of ways we can decrease gas emissions on an everyday basis, including avoiding the use of diesel cars and instead walking or using electric vehicles, or installing solar panels on roofs.
Although that can be expensive, doing little things every day like turning off heating during the night or walking to places that are in your local area can help you reduce your carbon footprint.
The only thing is that some of us will do it, but the others of us won't, and use the car so much more than necessary.
We're not by any means saying that you shouldn't use the car, but if everyone used it a little less, then it could hugely benefit the Earth.
Welcome to Ceres Reimagine 2023, our clean energy competition. I'm Caroline Hargrove, Chief Technology Officer for Ceres, and I'm thrilled to
85% of homes in the UK and 23 million properties rely on the gas network. However, natural gas is a finite fossil fuel which releases greenhouse gases, methane and carbon dioxide into the atmosphere. In fact, burning natural gas accounts for 37% of all CO2 emissions in the UK. The anthropogenic greenhouse effect is an ever-increasing concern as we discover the significance that the melting ice caps, thermal expansion of oceans, biodiversity loss and increased frequency and intensity of natural disasters has on our environment, communities and economy. To meet the government's net zero target by 2050, we have to find a viable alternative.
An alternative production method and energy storage system is green hydrogen, which is obtained from the electrolysis of water. If the energy input is obtained from renewable energy, like solar, the system can produce energy without emitting any CO2 into the atmosphere. This works by water passing through an electrolyzer and reacting at the anode to form oxygen atoms and hydrogen cations. Electrons flow through an external circuit and the cations move to the cathode, where they are attracted to the negatively charged electrons to form hydrogen atoms.
Although the nation's end goal is to cut carbon emissions by 95% by 2050 to reach net zero, it is unrealistic to think that this could happen overnight. We do not currently know whether running our homes completely off hydrogen gas is compatible with our existing pipe networks or appliances, so our idea for initial steps that must be taken include introducing a legislation that all new properties must be built with hydrogen-compatible appliances.
Scientists in Long Island, USA have begun to experiment with hydrogen blending. This process aims to integrate hydrogen into our existing natural gas pipe networks, reducing CO2 emissions, our reliance on finite fossil fuels, and encouraging the use of hydrogen as a fuel for domestic purposes, one step at a time. If we in the UK add just 20% green hydrogen to our natural gas supplies, we would see the same carbon reduction of taking 2 million cars off the road annually.
There are many advantages to green hydrogen. It's efficient, sustainable, and does not emit polluting gases or leave residue in the air, either during production or combustion. It actually only emits water vapour. Furthermore, it has the ability to be stored, which allows it to be used subsequently and not necessarily immediately after production, as hydrogen gas can be converted back into electricity when it is needed in a fuel cell.
This may become more helpful in the future as electrolyzers develop and become more accessible, allowing our scheme to develop so people can generate their own hydrogen from solar panels on their roofs to create hydrogen homes, or even to fuel their cars, allowing people to live independently from the grid. Any extra energy produced could even be stored in hydrogen fuel tanks to be used when less is made, for example, during the night or on cloudier days when solar power is less efficient.
We believe that to reduce carbon emissions and build a more sustainable future, it is imperative to switch from natural gas to green hydrogen for cooking, heating, transport and more.
Welcome to our floating factory, also known as the floater, to produce sustainable energy.
We have designed a machine that can create a clean source of hydrogen, and since hydrogen only produces water when burned, it's a great source of energy without polluting the atmosphere. The machine is designed to float on the sea and be as autonomous as possible.
The machine works by reacting sodium metal with water to generate hydrogen gas, which we can collect. It also produces heat, which we can use to create steam and turn a turbine to generate electricity.
First, the machine takes a sample of seawater and begins to electrolyse it. This separates the solution into chlorine gas, hydrogen gas, and leaves behind a solution of aqueous sodium hydroxide. The chlorine gas can be collected and be sold to water purification companies. The hydrogen gas can be collected at the cathode and stored. Now on to forming the sodium metal.
The electrolysis reaction leaves behind a solution of aqueous sodium hydroxide, which is essentially a mixture of positive sodium ions and negative hydroxide ions surrounded by water molecules. We can evaporate off the water and be left with solid sodium hydroxide, which is our means of obtaining sodium metal.
This solid sodium hydroxide can be melted and electrolysed. This is called the Kastner process. It will create sodium metal at the cathode and water and oxygen at the anode. We now have our sodium and it is ready to be reacted. Onto the sodium reacting chamber.
The sodium reacting chamber is where our hydrogen is going to be made. The chamber consists of individual metal cylinders filled with water. They have a plate at the top which can be twisted round to allow sodium metal to fall into the water. Chambers have a hatch in the back which can be opened in order to place sodium metal on top of the plate. Once all the cylinders have sodium in them, then all the plates can twist down and drop the sodium into the water.
When sodium comes into contact with water, it reacts violently and generates hydrogen gas and aqueous sodium hydroxide. The hydrogen gas travels up to the top of the cylinder and through a pipe where it can be collected.
The aqueous sodium hydroxide can be released through the bottom of the cylinder once the reaction is complete. The water can be evaporated off and the solid sodium hydroxide can be melted and electrolysed again. This will give us our sodium back, which we can react again.
The reaction between sodium and water is very exothermic, meaning it gives out energy in the form of heat. The cylinders will heat up and in turn heat up the shallow layer of water outside the cylinders. This will create steam which will rise up the side of the cylinders and turn turbines on its way to generate electricity. This could be used to power the electrolysis reaction.
All the hydrogen which we collect can be used in hydrogen fuel cells to produce energy without creating lots of pollutants in the process.
When fossil fuels get burnt, they release lots of energy and carbon dioxide into the atmosphere, which act as a blanket around the Earth. The sun shines onto the Earth, which causes some rays to be reflected back into space, and some rays to be reflected off the Earth and absorbed by the carbon dioxide in the atmosphere.
The carbon dioxide then re-emits the radiation back at Earth, causing the Earth to warm. This is because carbon dioxide is good at absorbing and then re-emitting infrared radiation. Infrared light is felt as heat, and therefore it heats up the Earth. Our floating factory will help to reduce the pollutants that enter the atmosphere by providing a clean alternative.